Good morning. Today's quote is who questions much shall learn much and retain much. Who questions much shall learn much and retain much. Today's word is ephemeral. It is an adjective. Lasting or used for only a short period of time. Ephemeral pleasures or the ephemeral joys of childhood. Exercise 5.1, we are doing vectors. ABCDEF is a regular hexagon. Show that AB bar plus AC bar plus AD bar plus AE bar plus AF bar is 6AO bar. Okay, 6AO bar. So this is O. Now ABCDEF is a regular hexagon. So AB bar is ED bar. And what is AF bar? AF bar is nothing but CD bar. Okay. Now use triangle law of addition of vectors. See what you get. By triangle law, write down. By triangle law of addition of vectors, AC bar plus AF bar equal to AC bar plus CD bar equal to AD bar. See why are we interested in AD bar? Because AD bar is nothing but twice AO bar. That is why. And AE bar plus AB bar equal to AE bar plus ED bar, which is nothing but AD bar. Right then? Now left hand side, I have rearranged the terms and I have written LHS as AD bar plus AC bar plus AF bar plus AE bar plus AB bar. That is AD bar plus AD bar plus AD bar. That is thrice AD bar. Now O is midpoint of AD. So what is AD bar? Twice AO bar to get 6 AO bar, which is nothing but right hand side. So this is sum number 4. Now sum number 5. Check whether the vectors 2i cap plus 2j cap plus 3k cap minus 3i cap plus 3j cap plus 2k cap and 3i cap plus 4k cap form a triangle or not. Actually, I haven't just yet explained this position vector of a point in space. Okay, but you had done this in physics, so we will just solve sum number 5 and 6 and then I'll explain that part first so that we can solve remaining sums. Okay, so how to start the solution? Just write down. Whether the vectors form a triangle or not. Okay, so these must be the three sides, vectors along the three sides. Write down. Let if possible, write down. Let if possible, the three vectors form a triangle ABC. Let, comma, if possible, comma, the three vectors form a triangle ABC, with AB bar equal to, write down, AB bar equal to 2i cap plus 2j cap plus 3k cap, BC bar equal to, write down the given vector, 3i cap plus 3j cap plus 2k cap and AC bar equal to, what is that? AC bar 3i cap plus 4k cap. See, BC bar is minus 3I cap. Just check this. Okay. Therefore, AB bar plus BC bar. Actually, write these two vectors. The addition is what? Minus I cap plus 5j cap plus 5k cap. It is not AC bar. Or you may argue, but why are we taking first as AB bar and not BA bar? Okay, in that case, we are not even getting minus AC bar. Okay, just check this, 2I minus 3I. Okay, so not equal to AC bar. Therefore, vectors do not form a triangle. Vectors do not form a triangle. Right. Now 6th, in the given figure, express C bar and D bar in terms of A bar and B bar. What is PQ bar? It is PS bar plus SQ bar. Now S is a midpoint. So what is A bar? It is C bar minus D bar. What is PR bar? PR bar is nothing but PS bar plus SR bar, that is C bar plus D bar. Now add two equations to get A bar plus B bar equal to what? 2C bar. Right? 2C bar. So just a minute. I think that file is missing or what? Okay. It is missing. No problem. We will actually write that. See, A bar plus B bar is what? 2C bar. Now I will write the solution on slate. So what is C bar from this? Therefore, C bar is nothing but half A bar plus B bar. That is half A bar plus half B bar. Okay. Then put C bar in second equation. So D bar is B bar minus C bar. That is B bar minus A bar plus B bar upon 2. So can I write this directly? Half B bar minus half A bar. So we have expressed C bar and D bar in terms of A bar and B bar. Let me show you this part again. This is the given sum. S is midpoint of QR. Okay. Now PQ bar is PS bar plus SQ bar, that is A bar is C bar minus D bar. And what is B bar? C bar plus D bar. Add these two to get A bar plus B bar equal to 2C bar. So what is C bar? Half A bar plus B bar. Now put this in second equation. So B bar equal to, second equation is what? B bar equal to C bar plus D bar. So D bar is B bar minus C bar. Put the value of C bar to get this. So this is the answer. Actually, we have already discussed one important theorem. If A bar and B bar are any two non-zero, non-collinear vectors, then any vector R bar coplanar with them can be uniquely expressed as the linear combination. As the linear combination R bar equal to what? P1 A bar plus T2 B bar, where T1, T2 are scalars. Okay, and this representation is unique. Now, from this, we can say that if A bar, B bar, C bar are coplanar vectors, this is very important, then any one of them can be expressed as a linear combination of other two. So if you are asked to prove the coplanarity of three vectors, see, two vectors are always coplanar. The question arises in case of three or more vectors. So that coplanarity can be proved using the fact that if three vectors are coplanar, then one can be expressed as linear combination of remaining two. Okay. After that, we just discussed three non-zero vectors A bar, B bar, C bar are coplanar if and only if there exist scalars x, y, z, not all zero simultaneously, such that xa bar plus yb bar plus zc bar, which is nothing but 0 bar. Okay. Now, we discuss vectors in 2D, two dimension. That is position vector of a point in the plane. These are two mutually perpendicular lines. This is x-axis, this is y-axis. Okay. Now we consider I cap and j cap as two unit vectors along positive directions of x-axis and y-axis. So I cap in the positive direction of x-axis and j cap in the positive direction of y-axis. Okay. Consider any point pxy in the plane. For convenience, I am considering point in the first quadrant, but it may lie in any quadrant. It may lie on one of the two axes also. Okay. Draw perpendicular PM and PN on x and y axis respectively. Now you will notice that OM is nothing but x and ON is nothing but y. Now OM bar and I cap are collinear. If two vectors are collinear, one can be expressed as a non-zero scalar multiple of other. So what is OM bar? OM bar is nothing but xi cap. And what is ON bar? Note that ON bar and j cap are collinear. So ON bar can be expressed as a scalar multiple of j cap. So y j cap. Now quadrilateral OMPN is a parallelogram. So by parallelogram law of addition of vectors, what is OP bar, which is usually written as R bar? So it is nothing but OM bar, okay, plus ON bar. So what is OP bar? OP bar is finally XI cap plus YJ cap. So this is a vector in 2D. Okay. Now can you tell me unit vector in the direction of OP bar? It is OP bar upon mod of OP bar. Now mod of OP bar is OP. OP is basically the distance between 2 points, origin and pxy. We know that it is nothing but root x square plus y square. So unit vector in the direction of OP bar is OP bar upon mod of OP bar. Okay. So it is xi plus yj upon mod of OP bar, that is r. So x upon r I cap plus y upon r j cap. Is that clear? So this is nothing but position vector of a point in the plane. Now we are interested in discussing position vector of a point in the space. Position vector of a point in the space, that is three-dimensional coordinate system. Now to express a vector in space in terms of unit vectors along coordinate axis, we require rectangular coordinate system in 3 dimension. See, in 2 dimensional geometry, we consider two mutually perpendicular lines. In 3D geometry, we have to consider three mutually perpendicular lines. We call them as x-axis, y-axis, and z-axis respectively. So these three are concurrent, and point of concurrence is nothing but origin. Now this is interesting. Two mutually perpendicular lines divide the plane in 4 parts. Three mutually perpendicular lines will divide the space in 8 parts. Each part will be called as an octant. See, it is impossible to draw a 3D diagram on this slate, which is 2 dimensional. And that is why you have to accept this, that yes, x-axis is perpendicular to both y-axis and z-axis. Now, how do we obtain coordinates of any point? Suppose P is any point in the space. From the point P, we draw perpendiculars, say PA, PB, and PC on 3 coordinate axes. The foot A of the perpendicular from point P on x-axis is associated with a real number, which is called as x coordinate of the point. Foot B is associated with a real number, which is y coordinate of the point. The foot C is associated with a real number, which is z coordinate of a point. And therefore we say that P has coordinates x, y, z. As I said, there are 8 octants. So how many combinations of signs? Plus, minus, plus 8 combinations can be remembered easily. See, plus, 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 minus, 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 plus, plus, minus, minus, plus, plus, minus, minus. Finally, plus, minus, plus, minus, plus, minus, plus, minus. Okay. So all are positive, x and y positive, z negative, up to all are negative. So these are the 8 different possibilities. Okay. Actually, you can use the analogy used in case of 2D geometry to discuss about position vector of a point in the space, that is in 3D geometry. But there are a few important things, that there are 3 coordinate planes. The first is XOY plane or just XY plane. The third one is YOZ plane or YZ plane. Then ZOX plane or just ZX plane. You have to use common sense. If a point lies in XY plane, its coordinates will be of which type? X comma Y comma 0. Why? Because Z coordinate will be 0. Because suppose point lies here, and if I ask you that the point is in XY plane, what is its Z coordinate? Simple. Try to draw perpendicular from this point on Z axis. So the foot lies at origin, right? And therefore, if a point lies in XY plane, its Z coordinate is 0 and so on. Okay. Now, if I draw one more diagram, you will notice that there are 3 planes which are parallel to coordinate planes. I'll tell you. This is origin. This is the point P I was talking about. This is y-axis. This is x-axis, and this is z-axis. See, these are the plane. This is actually from the point P, perpendiculars are drawn. So this is PA, this is PB, and this is PC. Okay. So see the cursor. This plane is parallel to XOY plane, right? Now YZ plane is this, and this plane, see the cursor, is parallel to YZ plane. This is ZX plane. See the cursor. This plane is parallel to ZX plane. Okay. Yes. Now we discuss components of a vector. The unit vectors along positive x-axis, positive y-axis and positive z-axis are denoted by I cap, j cap and k cap respectively. If A x 0 0, B 0 y 0 and C 0 0 z are the points on x-axis, y-axis and z-axis respectively, then OA bar and I cap, this is O. OA bar and I cap are collinear. So OA bar can be expressed as a scalar multiple of I cap. So xi cap. Similarly, OB bar and j cap are collinear. So I can express OB bar as a scalar multiple of j cap. Similarly, OC bar and k cap are collinear vectors. So OC bar can be expressed as a scalar multiple of k cap. So OA bar is xi cap, OB bar is yj cap, and OC bar is zk cap, right? Thus, any vector along x-axis is a scalar multiple of I cap. You have to remember this. Any vector along y-axis, scalar multiple of j cap, and any vector along z-axis is a scalar multiple of k cap. See, suppose I consider 7 I cap. How will you describe this? 7 I cap is a vector along OX whose magnitude is 7. Suppose I consider minus 3 K cap. Then it is a vector along OZ dash, that is negative Z axis. And what will be the magnitude of this vector? It is nothing but 3. Okay? Yes. See, we discussed one theorem in case of two vectors, and we use that to obtain position vector of a point in the plane. Now we are interested in obtaining position vector of a point in the space. Okay, so for that, which theorem is to be used? See, the statement is, if A bar, B bar, C bar, listen to me carefully, if A bar, B bar and C bar are three non-zero, non-coplanar vectors, then any vector R bar in the space can be uniquely expressed as a linear combination of A bar, B bar, C bar. I repeat the statement. If A bar, B bar, C bar are three non-zero, non-coplanar vectors, then any vector R bar in the space can be uniquely expressed as the linear combination of these three. You may take it as XA bar plus YB bar plus ZC bar. Okay. Now proof will be asked in exam. I'll explain the proof. This is O, here I will write A, this is B, and this is C. I call this as L, and this as M, and this as N. Now this is the point P. So this is say Q, and I can denote OP bar as R bar. Just listen to me. This is OP bar, which is R bar. Okay. Let OP bar represent the vector R bar, and OA bar, OB bar, and OC bar represent three non-coplanar vectors, non-zero and non-coplanar vectors A bar, B bar, and C bar respectively. Now through the point P, I have drawn planes which are parallel to the planes BOC, COA and AOB, intersecting the lines OA, OB and OC in which points L, M and N respectively. I'll again explain from the beginning. See, let OP bar equal to say R bar be the vector in the space, and OA bar, OB bar, OC bar represent three non-coplanar vectors A bar, B bar and C bar respectively. Now through the point P, draw planes which are parallel to which planes? BOC, COA and AOB, intersecting the lines OA, OB and OC in which points? L, M and N respectively. Now OL bar and A bar are collinear vectors. So there exists a non-zero scalar, say X, such that I can say OL bar equal to XA bar, right? Similarly, can I say OM bar equal to YB bar? And what is ON bar? It is nothing but ZC bar. See, instead of taking XYZ, you can consider other scalars also, but do not take ABC because small a is the magnitude of the vector A bar. Okay. Now, by triangle law of addition of vectors, can I say that OP bar is nothing but OL bar plus LP bar? Yes, I can. For that, you have to complete the triangle. Okay. So what is OP bar? See the diagram. OP bar is OL bar plus LP bar. But what is LP bar? I keep OL bar as it is. What is LP bar? LP bar is nothing but LQ bar plus QP bar. This is not at all difficult. Next part is important. So this is OL bar plus OM bar plus, can I replace QP bar by ON bar? Yes, I can. Note that it is a parallelepiped. Okay. So vectors along edges QP and ON are equal. So I can replace QP bar by ON bar. I hope you can appreciate this. Similarly, I can replace LQ bar by OM bar. See, this is a three-dimensional figure obtained, rather formed using 6 parallelograms. And vectors along the opposite sides of parallelogram are equal vectors, right? Now, what is the advantage of writing OL bar plus OM bar plus ON bar? Now I can say that OP bar, that is R bar, is XI cap plus YJ cap plus ZK cap. So we have proved the result. In fact, first part we have done. Uniqueness we haven't yet proved, but we have proved that if R bar, rather if A bar, B bar, C bar are any three non-zero, non-coplanar vectors, then a vector R bar in the space can be expressed as the linear combination. Now we have to prove the uniqueness. On the contrary, we assume that this representation is not unique. That is, we say, let if possible, R bar be Xi, rather, R bar be X dash I cap plus Y dash J cap plus Z dash K cap. So I have assumed that this representation is not unique. Now left hand sides are equal, so I can equate right hand sides to get Xi plus Yj plus Zk. See, many people say that you need not write I cap, J cap, K cap separate every time. By I we mean I cap, but in the textbook and even in exam you are supposed to write I cap every time. I cap, J cap, K cap. So Xi cap plus Yj cap plus Zk cap is X dash I cap plus Y dash J cap plus Z dash K cap. Okay. Now I'm omitting one step. I'm directly writing X minus X dash I cap equal to what? Equal to Y dash minus Y J cap plus Z dash minus Z K cap. Now we are saying this representation is not unique, right? So X minus X dash is not equal to 0. So I can divide by this scalar to get this. Okay. So here we have expressed I cap as the linear combination, of J cap and K cap. I'm sorry, I should have taken A bar, B bar and C bar. I'll let that part once again. I'm sorry. because we haven't yet defined position vector of a point in the space. So we have obtained R bar as what? Basically XA bar plus YB bar plus ZC bar. I'm sorry. Now I take this as R bar equal to X dash A bar plus Y dash B bar plus Z dash C bar. Assuming that this representation is not unique, equate right hand sides, rearrange the terms. So after dividing by X minus X dash, I get A bar as what? Y dash minus Y upon X minus X dash B bar plus Z dash minus Z upon X minus X dash C bar. Note that here A bar is expressed as linear combination of B bar and C bar, which is absurd. Why? Because vectors A bar, B bar, C bar are given to be non-coplanar. If three vectors are non-coplanar, we cannot express one as the linear combination of remaining two. This has happened because of wrong assumption. We assume that representation is not unique. That assumption is wrong. Representation must be unique. I hope this is clear to you. So can I say now that if A bar, B bar, C bar are three non-zero, non-coplanar vectors, then a vector R bar in the space can be uniquely expressed, as the linear combination of A bar, B bar, C bar. We may write it as R bar equal to X A bar plus Y B bar plus Z C bar. Now we use this to obtain position vector of a point in the space. So Pxyz is any point in the space. Same logic, we draw perpendiculars, say PA, PB, PC on three axes. So the feet are associated with real numbers. We have just seen, now I will write this directly, that this is origin. So three vectors xi cap. I hope this is clear to you. We have just discussed that OA bar and I cap are collinear, right? So OA bar can be written as what? As xi cap. So xi cap, yj cap and zk cap are what? Three non-zero, non-coplanar vectors. So vector OP bar, that is R bar, can be expressed as R bar equal to xi cap plus yj cap plus zk cap. Now, as per the theorem, this representation is unique. So, if Pxyz is any point in the space, its position vector OP bar is given by xi cap plus yj cap plus zk cap. What will be the magnitude of this vector? It will be just OP, which is R, which is root of x square plus y square plus z square. Okay. Now when I say R bar equal to xi cap plus yj cap plus zk cap, then xyz, see this is important, xyz are called components of R bar or rectangular components. Components of R bar along x-axis, positive x-axis, positive y and positive z-axis. Okay. Yes. Now, next interesting part. Suppose this is origin, this is A, this is B. These are the 2 points. OB bar is B bar, OA bar is A bar. Now, by triangle law of addition of vectors, clearly OA bar plus AB bar equal to OB bar. Do you agree with me? By triangle law of addition of vectors. So what is AB bar? AB bar is always OB bar minus OA bar. This is very important. What is AB bar? It is OB bar minus OA bar. O is origin. But OB bar is B bar. And what is OA bar? It is A bar. This means position vector. Listen to me carefully. Position vector of the point B with respect to A is what? B bar minus A bar. If I ask you what is EF bar? EF bar is position vector of the point F, which is usually taken as F bar minus what? Minus E bar. Okay. So if I take A as x1, y1, z1 and point B as x2, y2, z2. Okay. Can you tell me what is AB bar then? AB bar is nothing but position vector of the point B, that is B bar, small b bar. Never write capital B bar. Small letters are to be used, minus A bar. Okay. Now I will omit one step. What is B bar basically? X2 I cap plus Y2 J cap plus Z2 K cap less X1 I cap plus Y1 J cap plus Z1 K cap. I will directly write x2 minus x1 I cap, not at all difficult, plus y2 minus y1 j cap plus z2 minus z1 k cap. Right. Now, what is magnitude of vector AB? We have seen the working rule. It is square root of sum of the squares of components of R bar or AB bar in this case. So it is root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is nothing but distance formula in case of 3D geometry. I hope this is clear to you. You have to remember that what is AB bar? AB bar is nothing but position vector of B with respect to A. So AB bar is B bar minus A bar. Sum number 7. Find a vector in the direction of A bar equal to I cap minus 2j cap that has magnitude 7. Now A bar is I cap minus 2j cap. So what is mod of A bar? Now you will ask me, we are asked to find vector of magnitude 7. So why are you obtaining unit vector? See, initially we do not know what is the magnitude. So the best way is obtain unit vector in the direction of A bar and then say that we are interested in finding a vector whose magnitude is 7 and which is in the same direction. So just scalar multiple of that unit vector. Okay. Yes. So what is unit vector along A bar? It is A bar upon mod of A bar. And vector of magnitude 7 along A bar is 7 A cap. A cap is what? Unit vector in the direction of A bar. So simplify to get 7 by root 5 I minus 14 by root 5 J. Please do not put dot here because dot stands for dot product. Somebody is saying this is sum number 6, is it? Now sum number 8, find the distance of 4 minus to 6 from each of the following. Okay, suppose the given point is P4 minus to 6. See, I have drawn this diagram just to explain how to get distance of a point from XY plane. I know that for the point P, all the three coordinates are not positive. Okay, but still, see, P is the point. Now, what is the distance of this point from XY plane? This much is the distance. Now, this edge is parallel to this edge, right? So, vectors along these two are equal. So, can you tell me this is actually the foot of perpendicular drawn from point P on Z axis, and we know that foot is associated with Z coordinate, right? But distance is never negative. So in the first part, I will just dictate it right up. A part, distance of P from XY plane. Distance of P from XY plane. Distance of P from XY plane equal to modulus of Z equal to mod 6 equal to 6. I hope you are getting this. See, we are basically asked to find this distance. Okay. So this distance is nothing but this one. Now this is Z coordinate, but distance is always positive, rather non-negative, but coordinate can be any real number. So mod Z, that is 6. B part. Write down distance of A from YZ plane. Distance of A from YZ plane equal to mod X equal to 4. Now in the C part, what is asked? Distance of A from ZX plane. Distance of A from ZX plane is mod Y equal to mod of minus 2, which is nothing but 2. Okay. So this is C part. Then D part. Don't depart. Be here only. Sub question D. The distance of A from X axis. I'm sorry, distance of, I should say P, because I have taken point as P. Distance of P from X axis. Can you tell me what is that distance? Yes, it is root y square plus z square. So tell me what is that? I'll write it directly. It is root 4 plus 36. That is root 40. You may simplify this as 2 root 10 unit. Now distance of P from remaining two axes. Distance of P from y axis. What will be that? It will be root x square plus z square. That is 16 plus 36, which is 52. 4 into 13. So 2 root 13. I have directly written this. And the last part, if distance of P from Z axis equal to root x square plus y square. That is root 16 plus minus 2 square is plus 4. Root 20 is nothing but 2 root 5. So these are the distances. Question 9, I think in the textbook it is question 8. That's why I'm reading the question first. Find the coordinates of the point which is located A, 3 units behind YZ plane, 4 units to the right of XZ plane, and 5 units above the XY plane. See, if we take point as XYZ, PXYZ, what is given? Point is located 3 units behind YZ plane, behind. So X coordinate is minus 3, right? I don't think such question will be asked in the exam, but we will discuss this. And again, what is given? The next part is 4 units to the right of XZ plane, right of XZ plane is given. So Y coordinate is 4 and 5 units above the XY plane, above the plane, XY plane is given and not below. And therefore, what is the Z coordinate? It is 5. Okay, so I will just tell you that required point is, just write down this, -3, 4, 5. That's it. Okay. Now, next part, uh, we begin with let coordinates of the point be x, y, z. Now, point is located in yz plane. Okay, so x coordinate is 0. Now, the point is 1 unit to the right of xz plane. So, y equal to 1. And what is given? And 6 units above xy plane and not below, above xy plane. So, z equal to 6. So, what is the point? Therefore, point has coordinates 0, 1, 6. Okay, right on. Now, let me read the next sum. Find the area of triangle with vertices 1, 1, 0, 1, 0, 1, 0, 1, 1. Actually, three vertices are given. So, we have to find lengths of the three sides. If that triangle is a particular one, for example, right angle triangle, we have ready-made formula, or equilateral triangle, we have ready-made formula. What is the area of an equilateral triangle? √3 upon 4 into side square. Or we'll have to go for that Heron's formula. Okay. So first find out length AB. We name the points as ABC. Find out length AB, BC and CA. Find out. So by distance formula, first we name the points as ABC. By distance formula, AB, BC, AC, each is √2. So triangle is equilateral. So what is the area? It is √3 upon 4 into side square. √2 square is 2. So √3 into 2 by 4, that is √3 upon 2 square unit. Right now. 11th, AB bar is 2i cap minus 4j cap plus 7k cap and the initial point A is 150. Find the terminal point B. See what is AB bar? AB bar is nothing but B bar minus A bar. So what is B bar? A bar plus AB bar. Now A bar, I am writing directly. What are the coordinates of A? 150. So it is I cap plus 5j cap plus OK cap, that is 0k cap, plus AB bar. What is AB bar? It is given to be 2i minus 4j plus 7k. Simplify. So this is nothing but 3i cap plus j cap plus 7k cap. So what is B? Usually from coordinates we obtain position vector. Similarly, from position vector of a point, we can obtain coordinate because this representation is unique. No two distinct points can have the same position vector. So that point is 317. So that's it for today.